Good evening, one and all. Welcome to the webinar session brought to you by Project Step 1. Which vaccine and why? New challenging strain of COVID-19 virus. Now, I like to welcome our speakers of today, Professor David Baxter, Dr. M.K. Shashidhara, and Professor Madhusudan Upadhyay. Welcome and thank you for joining us, Doctor. I'm Priya, your host and proud volunteer at Project Step 1. Project Step 1 is 100% volunteer free telemedicine service. We are 7-month-old initiative that provides free telemedicine to COVID-19 impacted citizens across 16 states in India's 18 languages. We have touched more than 50 million lives through 1 million teleconsultations. This has been possible because of our community of citizens, volunteers, doctors, and of course our counselors. Dear doctor and citizen, your 1 hour per day can save thousands of lives. Project STEM is an impactful citizen and doctors driven initiative and it needs to be spread wider to get COVID under control in India. Dear doctors watching this session, give a missed call to 080-4719-2219 to join the largest doctor volunteer group. I repeat 080-4719-2219. Citizens to volunteer, give a missed call to 080-619-2266. I repeat 080-619-72266. So, coming about this session, does the new mutation of coronavirus, which causes COVID-19, comes with a greater degree of infectivity? Severity that sends as the earlier strain of coronavirus. Well, will the coronavirus strain challenge the vaccine that has come? What is the latest update? Let us understand this in this webinar. Now, I like to hand it over to the Dr. M.K. Shashidhara from International Medical Graduate Bureau, Stock Post, NHS Foundation Trust, Deputy Lead for Quality, Global Training and Education Center, Honorary Senior Lecturer, Edge Hill University, to introduce the panel and giving the opening note. Over to you, Dr. M.K. Shashidhara. Doctor, you are in the mute.
Right. Thank you, Supriya, and thank you, Shruti, for organizing this. And good good morning to everyone in UK, and good afternoon or good evening to people who are joining from India. Without further delay, I'm just going to introduce my main speaker and the moderator for this session. So the first and foremost thing is what I'll do is I will quickly let me just introduce Professor David Baxter. David and I, we work together in Stockport. David is the Director of Medical Education at Stockport, but he's also got several other roles. David is a consultant in public health for Stockport. He's Professor of Clinical Medicine and an honorary senior lecturer public health medicine. I think the biggest thing which I know about David is his involvement in vaccines and immunology for more than 40 years of his career. And the biggest one is UK meningococcal carrier study in 2015, which won the winner of the study year for Public Health England. So they'd been very actively involved with controlling various different pandemics. Previously, he's been challenged by many other pandemics. He's also have to deal with on a regular basis for influenza outbreaks in the schools and the local community. But recently, this has been compounded by the new COVID-19. So whenever I have any questions regarding COVID or COVID vaccine, anything like that, I think immediately I take the phone and ring David, and he's the expert in that. David has been involved with several vaccine studies. He's also involved in coronavirus SARS-2 vaccine studies, which is still undergoing. He's actually got a clinic at 1 o'clock with regard to that. The main thing is David not only been involved with doing the vaccines, he's also involved in terms of training very people who deliver the vaccines. Can you imagine the amount of vaccine we need to provide? 55 million vaccines in UK and 1.2 number of population of India, if you consider. So you also need the healthcare workers to deliver the vaccines. So David Bean, he started the clinical vaccinology society many years ago. He was the founder and the director of that, and he's been doing this national immunization conference for the healthcare workers for the last 30 odd years. 31st year conference just finished in December, and he's got this responsibility of teaching and training them. That's David for you. If you want any questions around the vaccines and the new strains of the coronavirus, is Dr. David Baxter who is going to be able to answer that. In addition to that, to get some views in terms of what's happening, I've actually invited Professor Madhusudan Upadhyaya. He is now currently the professor head of Department of Emergency Medicine in KMC Hospital, Mangalore. Madhu and we did anesthesia together back in 1989 onwards, and I know Madhu has been in this field for many years with special interest in obstetric anesthesia, difficult area and patient safety, and he's also delivered the big Dr. Venkatrao oration in the Indian Society of Anesthesiology, and he also has the experience of working as a member of the obstetric anesthesia committee in World Federation of Society of Anesthesiologists and for the last 4 years, and he's been in the front line in terms of preparing for any kind of emergencies, being the head of department of anesthesia and intensive care, being a medical superintendent being the equivalent of the deputy medical director in UK, medical superintendent of the hospital itself for many years, and he also spent some time working in Sikkim, Manipal. He is going to moderate the session. At the end, he is going to pick some questions and ask David. So with that introduction, what I'm going to do is I'm going to hand over the table to Professor David Baxter. David, I got your presentation. You tell me when you want me to put it on. I'll put it on. I'll work with you.
Okay. Thank you, Shashi, for the invite. Really appreciate it. Thank you, Professor Upadhyaya. Really feel honoured that you're moderating this session. Had a good time when I was last in Mangalore. I keep asking Shashi for an invite back, but I don't seem to get one. So anyway, these things happen. Let's carry on, folks.
Do you want me to start the presentation?
Yes, please. Sorry, Shashi. So what Shashi asked me to talk about was really just to give an overview of where we are with vaccines, and perhaps talk a little bit about whether the vaccines would protect against the new variant strain. What I thought I'd do is do that in the context of looking at the Indian and UK SARS coronavirus 2 vaccine programs. So what I'm going to try and do is look at the program from India, look at the program from the UK, and not compare and contrast them because they're just different, but just talk about them. Very interested that I think yesterday you had your last pilot session of the program, which I understand goes live next week. So you're going to start vaccinating next week with one of two vaccines. So next slide, please, Sashi.
you want me to go to the next slide?
Yeah, next slide, please, Sashi. So, that's my slide, Sashi.
Is it come?
That's not my slide. Next slide on that. It should, no, it's not that one. Yeah, go back a slide, can you please? Go back a slide. Okay, let's just move on, please. That's not, next one, please. So, the virus, the coronavirus, which you can see on the left-hand side, was first identified in, coronaviruses were first identified about 1965, and they were identified as the cause of the, as the common cold. And 4 of them were identified at that stage, transmitted by the respiratory route. And they were identified as coronaviruses. And the reason for so calling them is, if you can see on the left-hand side, there's a virus, and you can see little knobs, little orange knobs sticking out of it, and they look a bit like crowns, hence the name coronavirus. So the family is coronavirus. The subfamily again is coronavirinae, and there are a number of different types: alpha, beta, gamma, and delta. And the natural host are vertebrates, animals, and possibly bats. The orange spike is known as the spike glycoprotein, and that's what the virus uses to attach to a cell. It's very much like a key and a lock. If you think of the spike on the outside as a key, that's what the virus uses to get into a cell through the lock, and the lock in this case is the ACE2 receptor. So you have a key and a lock. So that's how the system normally works. Any viruses are obligate intracellular pathogens, and any cell that expresses the ACE2 receptor can be infected, and viruses have to get inside cells to replicate. The primary sites of infection are epithelial cells of the respiratory and enteric tract, and you can get secondary sites of infection of things like kidneys, liver, and heart tissues. Should we move on, please?
Yeah.
Right. So let's give some thought. Just go back one slide, please, Sashi. If you imagine that the virus,
he's on that. He'll call you back. Yeah.
Can you go back a slide, please, Sashi? If you imagine that this is the virus here, and it uses this spike here, this spike glycoprotein, to attach to an ACE2 receptor. What we've been doing in developing vaccines is basically to block this spike glycoprotein. We block it usually with an antibody, and that's normally the body's way of doing things. If you can imagine, the body will recognize that it's being attacked by a virus, and it will generally produce what we call an adaptive immune response against key parts of the virus. And the key part is this spike glycoprotein, and we produce antibodies against that spike glycoprotein. Now, as I say, the body would normally do that. And as part of a natural response, it will produce antibodies probably within about 21 to 28 days. You'll see some antibodies appearing after a couple of days, a particular antibody, which isn't very effective. It then switches to a different antibody, which those of you who are into immunology will know is IgG. And that IgG antibody is very good at sitting on top of this key and blocking its action. And you can imagine if you've got an antibody sat on top of this, it can't attach to the ACE2 receptor, and that's how we have developed vaccines. So virtually all the vaccine types that have been developed are directed. The basis is to produce antibodies that are directed against this. Now, why can't we rely on the body's way of doing it? Because the body produces antibodies. The problem is, as we've said, that the body takes normally 21 to 28 days to develop an optimal antibody response. And you can imagine if the incubation period for this disease is on average 5 to 8 days, there's been an outcome of the disease before the body's response kicks in. So what we try and do is come up with a vaccine to pre-protect us by having antibodies in our bloodstream before we're exposed. Next slide, please, Sashi. Right, now, this is a vaccine that those of you in the audience that are vaccinated will be very familiar with. This is polio. India eradicated polio a number of years ago, and one of the mechanisms by which they did it was to use the inactivated polio vaccine. And you can see that it's a circular virus, and on the outside it's got some things called VP1, VP2, VP3, and then inside of that VP4. Now, if you think of VP1, 2, and 3 as the keys that the virus uses to attach to a poliovirus receptor on a cell, that's quite a reasonable analogy. And it's very similar to what we're seeing, what we're doing with SARS coronavirus 2. So in India, I think it's the, you'll have to forgive me, I haven't got the pronunciation right, but I think it's the Bharat Corporation. And I think they produced a vaccine called Covinex. Shashi, you'll have to correct me. I'm afraid these aren't the slides that I've been working to, so I'm going by memory here. But India has developed a inactivated vaccine, a whole virus inactivated vaccine, which will be the same as very similar to polio. As far as I'm aware, it's due to be starting to be used, I think, in the next few weeks. And what happens is you inject the inactivated virus. So effectively, it's a dead vaccine. It can't cause disease or anything like that. And what happens is the body generates antibodies that, in the case of polio, will stick to VP1, VP2, VP3. They'll stick on top of it, block it, and therefore prevent the disease. The Chinese have been using inactivated, whole virus inactivated vaccines now for probably about 3 or 4 months, and I understand with pretty good effects. What side effects would you expect with them? Well, it's the sort of side effect you get with any vaccine. It would be there are usually 2 types. By the way, when I talk about side effects, I'm talking about expected events following vaccination, as opposed to adverse events, which are unexpected events. So what side effects? Well, these are common, aren't they? You'll all know them. They're the injection site reaction, and they are systemic effects. Injection site reaction, what are they? Well, redness and swelling at the site, tenderness, and occasional pain, coming on within a few hours and lasting 20 24 to 48 hours. Usually can last a bit longer. Systemic effects, fever, headache, achy muscles, achy joints. Those are the and fatigue. Those are the main side effects. So this is a one would expect this to be a very safe vaccine. I'd also expect it to be effective. As I say, I haven't seen all the trial results. I did look for them, but this vaccine, as I say, is going to be used as part of the Indian program. We're not using it in the UK. We're using largely gene vaccines, which hopefully is going to come next. What's next, Sashi? Next. Okay, come on. Next one, please. Right. What you can see here is you can see this molecule here on the left-hand side. This is actually the spike glycoprotein that the virus uses to attach to a cell. So this is what you produce antibodies against. And this here is the genome structure at the top. This is the genome structure for the virus. It's an RNA virus. It's a single-stranded RNA virus. It's got a big genome. It's got about 30,000 base pairs in it. And the genes that code for this spike glycoprotein, there are about 1,273 base pairs in it. Okay, so that's what we're producing. That's what we want to produce antibodies against. Next one, please. This is trying to show you what the immune response is. It's quite a complicated slide. If you think of the virus coming in at the left-hand side, the first part of the immune response is skin and mucous membranes. Skin's really good at keeping viruses out, as are mucous membranes. And then you have this innate response. And the innate response is absolutely critical in the immune response. The best way you'll see the innate response is, for example, when you have an acute infection, when you have a laceration or an infection on the skin, and you see redness and swelling, pain and tenderness. And what's happening there is an acute inflammatory response directed against either trauma or the pathogens that are trying to access through the lesion. And the innate response is really critical to controlling, amongst other things, SARS coronavirus 2. If the virus can get past that, there are 3 adaptive immune response, and I've colored them differently here. I've colored them green, I've colored them red, and I've colored them purple. The green are antibodies. So these are antibodies largely against the spike glycoprotein. Antibodies are really great while the virus is outside cells. Very good indeed. Once the virus is inside the cell, the antibodies can't get in, and so you have to have things called cytotoxic T cells, which recognize that cells are infected and kill them. And then coordinating this response are T helper cells. So you've really got 3 components of the adaptive immune response. And when you're looking at a vaccine, you need to ask yourself, does this vaccine generate 3 components? Does it generate antibodies? Does it generate cytotoxic T cells? And does it generate helper cells? And helper cells coordinate the activity of antibodies and cytotoxic T cells. T cells also help kill virally infected cells, and they also make the antibody, the IgM, the first antibody, switch to IgG, which is a better immune response. So the other vaccine that you're going to be using in India and that we're using in the UK, we've literally just started it last week, is the AstraZeneca vaccine. And what you need to be asking yourself is, right, does the AstraZeneca vaccine, does it generate antibodies? Which it does. Does it generate cytotoxic T cells, which I think it does? And does it generate helper T cells, which it does? So you're straight away thinking, this vaccine should work. This should be quite an effective vaccine. Now, with respect to COVID-19, oh, sorry, I should say this. In relation to the AstraZeneca vaccine, it's not as such the AstraZeneca vaccine you're using. I think you're using a vaccine produced by the biggest vaccine manufacturer in the world, which is the Serum Institute of India. And I think they're producing a sort of their own version of the AstraZeneca vaccine under license in India. So you've got an AstraZeneca-like vaccine being produced by Serum Institute of India. But as I say, when you look at it, when you look at the data, for those of you who are doctors or nurses or professionals involved in delivering the program, just be looking, do you get antibodies? Do you get T helper cells? Do you get cytotoxic T cells? Similarly with COVID-19, the inactivated whole virus vaccine that you're using. Same thing. Does it generate antibodies? Does it generate cytotoxic T cells? And does it generate T helper cells? Okay, so quite a complex slide, but really incredibly important when you're looking to control SARS coronavirus. We're trying to block the virus entering, and that's skin and mucous membranes. If it gets in, we're trying to regulate it by attacking it with the innate system, which you and I know as inflammation. And then if it gets past that, antibody, cytotoxic T cells, and T helper cells. I hope that's making sense. Is that making sense, Shashi? Is it making sense to you?
Yes, David, you may carry on.
Okay, so one of the things just to say is I always think of this as a sort of war. It's a war between, in this case, viruses and human beings. And it's not just one-sided. We've developed these responses. But actually, the virus has developed some responses itself. And what it's done is it downregulates, for example, one of its genes. It's got a gene called ORF1b. And that gene actually downregulates the innate response. So it actually makes, if I were to catch SARS coronavirus 2, the virus releases proteins that stop my innate system working as well. Okay, let's move on. Right. So we've talked about one vaccine. We've talked about the inactivated vaccine that you're using. And I hope basically what you do is you isolate the virus, you grow it in human cells, you inactivate it. Usually you put some aluminium in to act as an adjuvant, and that's your vaccine. Pretty straightforward, pretty standard. You've been using it for a long time with polio. You've been using it with hepatitis A. You've been using it with rabies, a whole series of vaccines that we give it for. The next vaccine we've used, and you're not using it currently, and that's a vaccine that's called a recombinant protein vaccine. And I'm just going to mention this because it helps to understand gene vaccines. So on the left-hand side is the hepatitis B virus. And on the outside, you can see these little white spots. Well, these little white spots are basically keys that the virus uses to get into a cell. And here, in red here, is the gene that the virus uses to produce or to manufacture these keys when it gets into a cell. So how do you make a recombinant protein vaccine? Pretty straightforward. You take the gene, you multiply it up so you get a lot of it. You then put it into a yeast cell and you tell the yeast cell to start replicating. It produces lots and lots of the keys. You purify the keys. Sorry, you harvest them, you purify it, and that's your vaccine. Now, my guess is most of the healthcare professionals working in the, most of the health professionals listening to this will have had a hepatitis B vaccine. That's how you make it. Now, let's see what the next slide is, Sashi. Okay, so just go back one, please. So there is now a recombinant protein vaccine for COVID. And all you do is you take the gene that codes for this spike glycoprotein on COVID. You take the gene, it codes for this. You insert it into a cell line. You get the gene to replicate. You produce lots and lots of spike proteins. You harvest them. And that's your vaccine. And that would be a recombinant COVID vaccine. Okay. Supriya, did you understand that? Supriya, are you there?
Hello, yes, Professor.
Did you follow that?
Yes, yes.
Okay, let's move on. You're gonna have to give me some feedback, Supriya, because I'm not using my slides. So I've got to make it if it's working. Okay, let's carry on, please, Shashi. And that would be that COVID-19, that's your subunit vaccine. That's your recombinant subunit vaccine. Now, you're not using that yet. I suspect you will soon. You've got a big population. If I remember correctly, I think you've got 1.5 billion people. You're hoping to immunize 300 million by July, which is a huge undertaking. But given what you've done in the past, I would be expecting you to do it. You will need, though, a multiplicity of vaccines, even if the Serum Institute of India is producing 2 million doses a week. You know, it's still a big undertaking. And it wouldn't surprise me if you come down with something like that. Let's move on. Right. Now, one of the problems when you deliver vaccines is they're broken down by the body very easily. And one of the things that we do is we often put them into what I would call taxis, rickshaws, or whatever, something, a taxi that enables the vaccine immunogen to get inside the body. And here you can see this little round ball here. Now that is a fat sphere. That's a little fat particle that's hollow in the middle. And what you do is you put your vaccine immunogen in the middle of that. So for example, in the recombinant vaccine that we're using, we put it inside in the hollow bit, and then we inject it. So the vaccine is the fat particle with the spike protein in the middle. It gets taken into the cell, and it then generates antibodies and cytotoxic T cells. And the little fat particles, which are known as lipid nanoparticles, they are important in making sure we get both antibodies and cytotoxic T cells. Next slide, please. Right. Now, if we go back a couple of slides, Sashi. One more. Sorry, forward one. I do apologize. Right. Now, some of you will start to think, well, hold on, that's pretty straightforward. You've got your gene that codes for this spike protein. So I'm using coronavirus. You've got your gene, codes for the spike protein. You put it into a cell. You get lots of it. You get it to replicate. You produce your spike glycoprotein, and that's your vaccine. Exactly the same as hepatitis B. So nothing to be concerned about with your recombinant vaccine. But some of you will say, well, hold on. Why bother doing this outside the body? Why not inject the gene directly into the body and get the body to produce the spike glycoprotein, which acts as the vaccine? Move on, can you, Shashi, please? Next. Stop there, please. And that is what a gene vaccine is. In a gene vaccine, instead of using the gene in vitro to produce the spike protein, which you then harvest and inject, which would be hepatitis B, you just inject the gene directly. So you inject the gene that codes for the spike glycoprotein, and that's a gene vaccine. Now, the problem you've got, if you go back one slide, Shashi, the problem you've got is that genes are broken down in the body. So if you inject a gene directly into the body, the various proteases and ribonucleases will just break it down. It won't last. You've got to get it into a cell. And so one way of getting it into a cell, which we've already seen, is to use a lipid nanoparticle. And so here's your lipid nanoparticle. It's hollow in the middle. Instead of having your spike glycoprotein in a recombinant, you put your gene in there. So you've now got your lipid nanoparticle with the mRNA gene inside. You inject that. The gene is released in here in the cytoplasm. The gene is transcribed. The gene therefore produces the spike glycoprotein. The spike glycoprotein is released. The adaptive into the extracellular fluid. The body's adaptive immunity recognizes these spike glycoproteins and produces antibodies against it. So that's your mRNA vaccine. That's your Moderna vaccine. That's your Pfizer vaccine. And as I understand it, India does have some Pfizer vaccine that will be part of the national program starting next week. Now, in the UK, we've been using the Pfizer vaccine for probably about a couple of weeks now. mRNA technology is very interesting. It's largely been used so far in relation to cancer, producing vaccines and drugs against cancer, and it has been successful. And what do you do? Well, you just take the gene, put it inside a lipid nanoparticle, and that's your vaccine. Now, the problem is mRNA is relatively unstable, so you have to keep it very cold. So you have to store it at about -60, -70 degrees Fahrenheit. And logistically, we've found this a huge problem. I don't know how you're coping in India. I suspect you're going to be okay with it. We found it a real problem. I mean, we've got over it. But you've got to keep the vaccine at -60 to -70. There's a limited time that you can use it in after you've taken it out. So after you take it out and defreeze it, you've got to use it within 5 days. So logistically, it's a problem. It's also, I think, quite an expensive vaccine. I think it's way more expensive than the AstraZeneca, and I suspect than the Serum Institute of India licensed AstraZeneca vaccine that you're using. But yep, Supriya, does that make sense to you?
Yes, yes, Professor.
Okay, let's move on. So we've now got our mRNA vaccine. Right, now what's that there for? Well, that is an adenovirus, and it is a different taxi. So remember, I've talked about one taxi based on the lipid nanoparticle. Well, this is a different taxi. So this is an adenovirus. Now, you and I have had lots and lots of adenovirus infections. We had them as children. They gave us a bit like common cold. You could have a bit of DNV. And what Oxford have done is, instead of using the lipid nanoparticle as a taxi to get the virus in, to get the SARS coronavirus gene in, instead of using that, because remember, if you try and inject the gene directly, the body will just break it down. So what they do is they use the virus, and they take the virus, they look at the genes inside the virus, and they cut out the genes that make it replicate. So they cut those genes out. So this is now a non-replicative virus vector. Now, you've got to put your gene in that codes for the spike glycoprotein. So you take out another gene that the virus doesn't need, and you replace it with the spike glycoprotein gene. So this now becomes a non-replicative viral vector spike glycoprotein vaccine. And that's your AstraZeneca vaccine. That's the one that the Serum Institute of India is producing under license in collaboration with AstraZeneca. And that's the vaccine that you're going to get as part of your program. And I think, from what I read in the Indian Express, that it's going to be the major component of the Indian program. Forgive me if I'm wrong. I was going by what I have been able to pick up over the last week or two from reading the press in India. So that's your AstraZeneca vaccine. Well, not quite. Because it's a human adenovirus, you and I, 80% of us, 90% of us will have antibodies against human adenoviruses. And there is a theoretical view that if we've got antibodies existing already against the human adenovirus, it will simply block the adenovirus, and the vaccine won't work. So what Oxford did is they said, right, we won't bother with the human adenovirus, we'll use the chimpanzee adenovirus, because the chimpanzee adenovirus is not pathogenic for humans, doesn't cause disease. So what they did was they took the chimpanzee adenovirus, they cut out the replicative genes, so it can't replicate. They cut out another part so that they could put the gene for the SARS coronavirus 2 spike glycoprotein in. And that now is your vaccine. It's a chimpanzee adenovirus vector, non-replicative, spike glycoprotein gene vaccine. Now, there are some advantages to this. For example, compared with Pfizer and Moderna. Logistically, you don't need to worry about temperatures. sorry, you don't need to worry about very cold temperatures. I think I said that Pfizer you store at about -60, -70, Moderna -20, but the AstraZeneca, the Serum Institute of India vaccine, you store at 2 to 8. So that's the same as any vaccine. So logistically, it's much easier and it's much cheaper. I think it's about a fifth of the cost of Moderna or Pfizer. So again, it's very competitive in terms of cost, and it's very competitive in terms of logistics. But okay, are we all right with that? Does that make sense, folks, about what a gene vaccine is and what the 2 vaccines you're going to be using in India are? One is the inactivated virus vaccine, which I think, no, I'm not going to pretend I know I can remember the name. And then there's the Serum Institute of India, which is the chimpanzee adenovirus vaccine. Yeah, are we all with me so far? Yeah. Yep. Okay. But those are only a few of the things we need to think about. Probably for me, whenever I look at vaccines, I think of 3 things, and I'm thinking of it. To be completely honest, initially I only think about it for my kids, my wife, and my children. I move on to my patients afterwards. I've got to satisfy myself. I would give it to my wife and children, and if I can give it to them, I then think it's okay for my patients. And there are 3 questions I always have. Do I need it? Does it work? And is it safe? Those are the only 3 questions I really ask myself. Now, so do I need it? Well, if you look there on the top of the slide, it says, who is dying from COVID-19 and when? Analysis of fatalities in Tamil Nadu, India, by Edwin Sam Asirvatham et al. And it's in the Clinical Epidemiology and Global Health Journal, 2021. And what the author has done, together with about 7 or 8 other people, is they've looked at who dies of COVID. And it's a really nice paper. I'm sorry I can't show you the table. As I say, I'm not quite sure. My slide isn't there. So what does the paper show from Tamil Nadu? Really, what we know. Who dies? Age-related, gender-related, and comorbidity-related. Okay, age-related. All right. If you're under 65, your mortality is much lower than people over 65, and there's an increase in risk as age increases. I can't remember the figures. You'll no doubt Dr. Shashidari will be able to let you have my presentation at a later stage. But it's something like about, I think it's something like 21.3 cases per 100,000 population if you're 85 and above. And if you're 65 and above, it's about 3. And under 65, it drops down and drops down. And once you're under about 40, mortality is much less common. It's still present, but much less common. Okay. And straight away, I'm hoping you can see why in the UK, our program takes people who are 80 and above in care homes as the priority group 1 that our program, our national program addresses, and then we gradually move down the ages. Now in India, you've taken a slightly different approach, I have to say I've got a lot of sympathy with yours in that you've gone with healthcare workers first, and then essential workers second, and then age group third. And I think that I think there's I think I've got considerable sympathy with that. I think though with the UK one, what I would say is the way it's working out is we are doing 80 and above, but there are programs now running in parallel where we're giving it to healthcare workers as well. So hopefully we're going to get the best of both worlds. We're going to get the people at high risk, and we're also going to get our healthcare workers and our essential workers, because they're absolutely critical to keeping the system going. Right, who else is at risk? Well, so first of all, you can see straight away that I'm going to be at risk because of an age-related function, rather than all the youngsters on the panel with me. What else? Well, I'm a male, and males have twice the risk, for example, than females do. Again, if you look in the paper from Tamil Nadu, I think it's something like about 3.48 compared with 1.58, something like that. There's twice the risk for men as females. So, from my point of view, I'm high risk. I'm older, and I'm male. And then you think, what about comorbidity? Well, comorbidity is a factor. And if you've got underlying comorbidity, hypertension, diabetes, heart disease, COPD, you have an increased risk. And it varies for the particular comorbid condition. Now, quite a few years ago, I had a heart valve repair that could have worked better. Let's put it like that. And that would put me in a risk group again for that. So straight away, remember what I said. I've got 3 questions when I look at a vaccine. It's in relation to my children, my wife, and myself. Is it necessary? Does it work, and is it safe? Right. Okay. So, is it necessary? Well, certainly for me. Very probably for my wife. My wife is Jamaican, so she's a Black Asian minority ethnic group, and we know that the mortality is higher. It's not. I don't think that I think the mortality as such is equivalent, but in the UK, BAMEs have a higher incidence of disease. So although the mortality is the same between the two groups, because Black, Asian and minority ethnic people have a higher incidence of disease, you see obviously more deaths in that community. So having looked at that, I'm sort of thinking, yep, need the vaccine. So then the next question is it safe and does it work? Do you want to put the next slide on, Sashi? And so this is your virus vector. This is your so this here is your chimpanzee adenovirus. These are the genes inside it. These are the keys the virus uses to normally infect us. What you do is you cut that gene out, which is associated with replication. You cut that gene out because it's not needed. You stick your SARS coronavirus 2 spike glycoprotein gene in there, and then you just inject that. That's your vaccine. Pretty straightforward. So this is simply acting as a taxi. But it can't replicate, so it can't cause disease because you've cut out the replication component, and you've got your gene in there. Next one, please, Shashi. Next one. Next one. Next one. Next one. Next one. So next one. Go on. Next one. Next one. Go back, please. Sorry, if you don't mind. So here you are, folks. I'm sorry. They've been coming out in and out of order. So here you've got your whole virus inactivated vaccine. We've talked about that. We've talked about our recombinant vaccine. Now, you don't have that in India. The only reason to talk about that is to understand it in relation to gene vaccines. And we've talked about the 2 gene vaccines. We've talked about this vaccine which you've got, and we talked about this vaccine which you've got, which is the non-replicating virus vector delivery system, which is the Oxford type approach. I think there's only 3 types of vaccines for corona. There's the whole, protein, and gene, and we've talked about this one. Next one, please, Sasha. Next one, please. 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 You can just carry on changing them, Sashi, if I just carry on talking, if you don't mind. So next question is it safe? And so what you need to do is to look at how do we assure that vaccines are safe? And the usual thing we do is we do 2 lots of studies. We do animal studies, and then we do human studies. In the animal studies, basically what we're trying to say, right, yeah, that's right. Is it safe? You can carry on, Sashi. Right, okay, we're back on track. How do we know if a vaccine's safe? Well, is it licensed? And licensing depends on doing preclinical and clinical studies. Preclinical are animal studies, and clinical are human studies. And so you're looking to see, does it work in animals? Preclinical. Clinical, next one please, Sashi, is divided into 4 phases. In phase 1, you give it to usually 10 or 20 people, no more than that. And really you're trying to find out, is it safe? Or are there going to be any adverse events? Remember, adverse events, things that we don't expect. We do expect sore arms. We do expect a bit of achy muscles and fever, but we all know that. This is, are there any adverse events? Is there anything serious that's coming up? And that's a phase 1 study. If phase 1 works, you then move on to phase 2. And in phase 2, you're probably giving it to several hundred people. Again, what you're doing here is seeing, is it safe? Are there any adverse events? What are the side effects? What's the immune response? Do you get antibodies? Do you get cytotoxic T cells? Do you get T helper cells? And if it passes phase 2, you then move on to a phase 3 study. And in a phase 3 study, you're giving it to, you're giving it to thousands of people this time. And I'm currently doing a phase 3 study with a recombinant protein vaccine. And we've recruited 15,000 people into the study in a number of sites across the UK, I hasten to add. And the classic phase 3 study is the randomized clinical trial, where you take half your group, 7,500, you take your other 7,500. The first group get vaccine, the trial vaccine, and the second group get placebo, so they get saline. Now, one of the things I didn't say with the animal study is very straightforward. You take your groups of animals, you inject them with a vaccine, you see if they generate antibodies, cytotoxic T cells and T helper cells, and then you expose them to the virus, and you see basically, do they survive? And that's your animal studies. Now, in a phase 3 study, you can't do that. Obviously, ethically, it wouldn't be appropriate. But you've got your 7,500 people, for example, in our study who've had vaccine, 7,500 who've had placebo. Now, no one knows what they are because it's a double-blinded study. It's a randomized, phase 3, placebo-controlled, double-blinded recombinant vaccine study. Now, as I say, you can't expose the population intentionally to virus, but we do know that however good masks are, however good hand washing is, however good social distancing is, however good track and trace or whatever systems you're using are, there will still be some people who will get SARS coronavirus 2 over the coming few months. And so what we do is we simply now follow up our two groups of people, and we see how many develop disease in the vaccinated group and how many develop disease in the placebo group. And the difference between them, because you'd expect fewer cases in the vaccine group if it works, what the difference between them is protective efficacy. And on the basis of that approach, Pfizer have said that their vaccine is about 90 to 95% effective. Moderna have said the same. Oxford have said that their vaccine is between 62% and 94% effective. And depending on the way you formulate the vaccine, it's about 90% plus effective. And so those are your efficacies of your vaccine. Okay, those are two more things to look for when you're looking at your inactivated vaccine and your Serum Institute of India vaccine. We've talked about looking at the immunological features, the antibodies, we look at T helper cells and cytotoxic C cells. Look at the efficacy, and also look at the efficacy in different age groups. Does it work in old people like me? Because as you get older, your immune system's less effective. So you really want to know, does it work? And just to let you know, Oxford does. Oxford looks really good in older people. And then the other thing to look at is, does it stop people getting seriously ill? Does it stop them being hospitalized? Because it's okay stopping people getting a cold, but we're not particularly worried about that. What we're worried about is, can we stop people getting serious disease and being admitted to hospital? And again, the Oxford vaccine looks really good at stopping people getting serious disease. So is it safe? Let's carry on. Again, you need to look at your manufacturing governance. Is it being produced under rigorous manufacturing conditions? Well, Serum Institute of India is the biggest one in the world. It's got a large portfolio. It works with a number of major pharmaceutical companies. So I'm assuming manufacturing governance is excellent. Next one. So, yeah, is it safe? Side effects. Next. And then, is it safe? Go back, please. That's it. Is it safe? Adverse events. Okay, so on the data that I've seen, now I'll be honest, I have not seen data about the inactivated vaccine that you're going to be using in India. I've not seen data on the adverse events of the inactivated or the vaccine being made under license. But I'm assuming, to be honest, that it's equivalent to the one that we're using in the UK. I'm assuming it's exactly the same. So what you find is, you do find side effects. 40–50% of people will get a side effect, and it will be a local injection site reaction, and it'll be a systemic effect. Redness, swelling, tenderness, and pain at the vaccine site, coming on within a few hours, lasting 24, 48, 72 hours. And then the arthralgia, myalgia, fatigue, headache, and fever, coming on within 24 hours, lasting 24, 48 hours. So that's those are your side effects. At the moment, I'm not seeing any data suggest there are any serious adverse events. Obviously, anaphylaxis has been an issue, and they've looked at certainly that's been an issue for us with Pfizer. I've not seen that as an issue with the Oxford vaccine, other than the 1 in a million people who have an anaphylactic reaction that you get normally with any vaccine, Hep B, polio, rabies, whatever. So first of all, do I need it? Yes, I think I do, because I'm male, I'm older, and I've got comorbidity. Right now, in India, I think you've gone. I think your program is healthcare workers, essential workers, and then you work down. Then I think it's 50 and above, 50 years of age and above, and you've divided them into groups 60 years and above and under 60, which seems pretty reasonable thing to do. And certainly, if you look at the Tamil Nadu data, that would make quite a lot of sense to do something like that. So that seems to work quite well. Is it safe? Yeah, I'm okay with that. Let's move on, can we? So I guess we've looked at does it work, haven't we? Because we've looked at efficacy. Efficacy is 95%, 90 to 95%, which is astonishing for first generation vaccines. That's as good as Hep B. That's as well, yeah, it's as good as polio. Really very good vaccine. So anyway, India, you're going to, we've looked at that, haven't we? Your program looks at hospitals, clinics and mobile units to deliver it. You had a practice run yesterday. You're going to be producing 100 million doses every week. I understand that there's little vaccine hesitancy in India. That's good. We've got quite a lot in the UK. We've got quite a lot of hesitancy, which we're addressing. And I think we're addressing pretty successfully, but it's work. You've got to work with people. You've got to address, and there are lots and lots of myths and disinformation and misinformation. Misinformation is just wrong information. Disinformation is where it's deliberately wrong, and one does have to address this. Okay, next one, please. Okay, so I think Can I carry on for a couple of minutes, Shashi, or do you want me to stop now? Shashi?
You may take another 4 minutes, maybe. Then last 10 minutes, we can have the discussions, David.
Okay. Okay. So if we stop. Oh, I should be asking the chair. Apologies. Right. That's it. So these are the two programs. You've got India and UK. You've got 1.5 billion. We've got 67.9 million. We're hoping to do 15 million people in our 4 priority groups by the 15th of February. And that's one of the things I'm going to do when I leave here. I've got to go and do a clinic. You're hoping to do 300 million by July. We've looked at the different, we use a very similar program to yours. Currently, you had an additional practice run yesterday. We've done 1.5 million so far. We're going to be using Pfizer, AstraZeneca. So Pfizer, remember, is the mRNA vaccine. AstraZeneca is the non-replicant virus vector spike glycoprotein. Moderna was just licensed yesterday morning, so that's another mRNA vaccine. They're both very expensive, Pfizer and Moderna. Yours is, oh, that's it, Covishield and Covaxin. So Covaxin is your inactivated whole virus vaccine produced by Bharat Biotech, and Covishield is your Serum Institute of India. Public and private healthcare workers, yeah, and then frontline, and then population above 50. So that seems a pretty straightforward, and then your remaining population, so that seems pretty straightforward. Ours is residents of care home, older staff working in care homes, 80 and above, 70 and above. The 80 and above is frontline health and social care workers. Now, as I say, we've conflated residents and 80 and above into one group, so we're running them basically in parallel. So I think, next slide. We'll leave that one. So I'll take any questions. I'll perhaps just answer one question before it comes up, which is we've seen, I think we've seen 2 new strains in the UK. When I say I think, there's quite a lot of dispute amongst the virologists I know about whether we are seeing new strains in the UK which have enhanced transmissibility. Now, I've heard the Prime Minister, and he, I'm sure, gets the best possible advice, saying that there is a new strain which shows enhanced transmissibility. The only thing I would say is that there is something that you can get with viruses called founder effects. I'm not going to go into it. I don't know enough about it. But you can see the spread of a virus simply due to the fact that that's the virus that's there, and that therefore spreads amongst people, and as such would appear to transmit to large numbers of people. You could then say it's got enhanced transmissibility. It's really key to know whether we are seeing new strains, because if we are, and there's enhanced transmissibility, that's got, for example, implications for control, and it's also got implications for whether vaccines work. Now, what I'm hearing is that the vaccines that we're using will be effective against these new strains. Now, that's the best I can tell you. I could go through quite a lot of data, which I probably don't understand sufficiently well to discuss it with you. But the bottom line that I take from the data I've heard and from what people are telling me is that the clever people I listen to are saying that the vaccine will protect. So thank you very much indeed for listening. I hope that was useful.
Thank
And
you.
Yeah, absolutely, David. I think you have covered almost all the things. Shall we just quickly go through the questions from the chat box? The first question is, anyway, you have just answered. Will existing COVID-19 vaccines work against the new strain? You said yes, it will work. And we also have it in the media saying that it works. I think that's fair enough. There's enough evidence, as you said, that it works against the new strains. And the question number 2 is, are there any other variant apart from the one identified in UK? Does it make people sicker or more likely to die? What are the new symptoms?
so I'm aware of, by the way, Dr. Apadya, sorry if I've been talking to other people rather than yourself. I do apologize for that. I should have been asking you because you're chairing it. So I'm aware of 3. I'm aware of a mink strain in Netherlands. I'm aware of what we call the Southeast England or Kent strain, and I'm aware of one in South Africa. Those are the 3 that I'm aware of. Does it make people sicker or more likely to die? To be honest, I think you're better to answer that, because you see far more patients than I do. I mean, I've got a view on it, but do you want to have a go at that, or
No, basically, we have had very few cases who traveled from UK, carried the strain into India, and we haven't had them for long enough to know how they present and how worse they are compared to the regular strain. Therefore,
right? Okay, so I was chatting to one of my intensive care unit colleagues this week, and I was also chatting to one of my acute medicine colleagues, and from talking to them, I get the impression people aren't necessarily sicker with these. That's what I'm hearing. I think what they're seeing is they're seeing people earlier in the course of illness rather than later on, as perhaps happened with waves 1 and 2. But what I'm hearing is that the people are no sicker. Now, that may be in part because of proning. It may be because of NIV. They're not making as much use of endotracheal intubation and ventilation. It may be remdesivir. It may be dexamethasone. It may be more prudent use of antibiotics. But I get the impression they're not necessarily any sicker. I hope that's correct.
yeah, we too hope so, because we need another almost a year to cover all the 1.5 billion population. Therefore, we need to have people much safer without being more sick.
Yeah.
I think that's quite encouraging, David. The third question would be, We have heard that tiny genetic changes happen as the virus makes new copies of itself to spread and thrive. Obviously, the genetic mutation, does it happen, and is it true?
So the answer to that is yes. It happens every time a virus replicates. I told you that the number of base pairs in the virus is 30,000. So every time one virus particle replicates and make another, it mutates at about 1 in 10,000. So you'd expect to see 3 amino acid changes per virus. Now, this comes back to some of those changes will have no effect whatsoever. Some will be deleterious. And the virus may just, I was going to say die, but that viruses aren't alive, so it doesn't make sense that. But a virus won't replicate any further. Some may lead to change. And this is where it's so important to find out if the change that you see in the genetic code is clinically significant. Does it make the virus easier to transmit? And does it, for example, make the illness more serious? Now, that came back to my earlier question, which is colleagues who are virologists that I respect hugely say to me they're not sure whether this is a founder effect or a true emergence of a new strain with enhanced pathogenicity. Now, my Prime Minister says it is a new strain with enhanced transmissibility. So you've got lots and lots of excellent virologists in India. Talk to them and see what their views are.
Sure, but but there are not many laboratories in India which can isolate these new strains.
Yep.
To be frank, in our state of Karnataka, we have only one lab, which is situated in Bangalore. Therefore, if somebody travels 500 kilometers away from Bangalore and reaches his home when he has traveled all the way back from UK, it's a little difficult to swab him and then send the swab to Bangalore and get the pathogenicity of, or rather look at the mutated virus.
Yeah,
that's a little bit of a practical difficulty, but I'm sure over the next few weeks we should be able to decipher what is in offer.
And the other thing, of course, is there are some really good places. I mean, the World Health Organization's got a lot of very good technical resources. The European Centre for Disease Control, Public Health England, the Centre for Disease Control in the US, and China's got a number of very good virological facilities. So it's a question of keeping on top of these and looking at it.
Okay. I think Shashi tells me that there is another webinar coming up next week about Indian vaccines. Meanwhile, the next question would be, should those affected by COVID disease take the vaccine? And if at all, yes, should they check their antibody levels?
So the current advice in the UK is yes, you should have a vaccine. Why? Because it's not, first of all, it's not known whether the antibodies generated are protective, because we don't know what the immunological correlates are, and we don't know how long they would last. So what our approach is that once you've recovered from the acute illness and say 4 weeks have passed, you should have the vaccine. There is one caveat, is if you've developed long COVID, any of the long COVID syndromes that people talk about, you would want those to be stable before you vaccinate the individual.
Okay. 4 weeks is 4 weeks is the time period after the disease.
That after the disease, you've had an acute illness, it's cleared up. 4 weeks later, okay, you have the vaccine.
Irrespective of the antibody titer.
Well, again, that comes back to the very first point, which is we don't know what the immunological correlates of immunity are.
Yep.
And being completely honest, I don't think antibodies per se are completely protective. I think what you need you need helper T cells, and you need cytotoxic T cells. So I think you actually, if you're going to measure immunological response, antibodies great, but also measure T helper and cytotoxic T cells. But in the context of a national program, I would not recommend measuring antibodies. We don't know how to interpret them, and we don't know how long they last. Get the vaccine and get yourself protected.
Okay, thank you so much. Should we be worried about the side effects these vaccines cause? Because the social media is agog with, even the print media is agog with the side effects the people have suffered and occasional deaths because of the anaphylaxis. Should we be worried?
Well, I think we should use our experience and understanding to make sure that we deliver the program safely. So what do I mean by that? I know that anybody I vaccinate, whether it's somebody I'm giving hepatitis A vaccine to, or flu vaccine to, or a polio containing vaccine to, can have an anaphylactic reaction. I work with lots of staff, and we make sure that we know how to recognize them, we know how to manage them, and we carry the drugs to deal with them. And so, although anaphylaxis doesn't terrify me, but it worries me. But it's controlled worry. We have a team approach. Before we start any session, we say, right, the first person coming in is going to have an anaphylactic reaction. Right, where are the drugs? Who's going to look at the patient? Who's going to make sure we get an ambulance? Who's going to make sure we scribe things down right? Who's going to get the defib? So we practice that every day. Now, in terms of side effects, what side effects? Well, we're talking about local injection site reactions, which are redness and swelling, pain and tenderness. We get that with all vaccines, and that's due to pro-inflammatory cytokine release at the site of injection. And then we get the systemic effects, don't we? We get a bit of a headache, a bit of fever, achy muscles, achy joints, fatigue, lasting a couple of days. And perhaps with these vaccines, they're slightly more reactogenic, and perhaps 40% of people will get this, or possibly even 50%, but quite manageable. NSAID for a local reaction that's extensive, and paracetamol for a fever. So I don't see that as an issue. I think what people are talking about are adverse events. Now, adverse events are what you don't expect. And obviously, when we started, we're thinking, what can happen here? If you're going to get an adverse event with a vaccine, normally they come on within a couple of months. That's what the general expectation is. It's pretty uncommon after 2 months for you to get other adverse events. You know, obviously you think of things like Guillain-Barré, but you're normally looking at 2 months. Now, we've been giving, for example, Pfizer now, we've given 1.5 million doses in the UK, and we've been giving it now for about 2 weeks. Now, so big numbers now, but if you look at the studies, the phase 3 studies, they were giving it to 40,000 people. So 20,000 had the vaccine. They've been followed up now for several months, and no adverse events have come up yet. Now, don't get me wrong, I'm not saying, oh yeah, everything's great. I'm not saying that. I'm saying we have to be cautious, and we have to be really cautious. But at the moment, the data is looking, I think, very secure at this moment in time. And given my risk of death, because of my age, my gender, and my comorbidity, I think that risk balance is different for me than, say, Supriya. Supriya, I don't know how old she is. She looks about, say, I don't know, let's say she's 30 or whatever. Now, if she gets it, very unlikely. Oh, I'm sorry, Supriya, you might be much younger than that. If you are, I do apologize. But what I'm saying is the risk balance for her is different for me. And I'm more prepared to take perhaps a slightly higher risk of an adverse event because I've got a much higher risk of dying. Does that make sense? So it's a question of making sure that you have good surveillance programs so that so if anyone does have an anaphylactic reaction, or if anyone does develop an adverse event, it's reported to our central groups that are coordinating these programs, and so that we can come up with accurate figures. You're a very IT savvy society. I would expect you to have very good data on adverse events. If you're going to immunize 300 million people by July, I would expect very, very, very good data on adverse events. If not, you're wasting an opportunity.
Correct. I agree.
We can send people to the moon or into space or whatever. I'd rather have a good surveillance program for COVID vaccines at the moment.
Does the protocol suggest that we check the antibody levels after the 2 shots?
No, because at the moment we don't know what correlates of protection are. I think what we do is we rely on the phase 3 studies, because remember, none of us are using licensed vaccines. The 2 vaccines you're going to be using in India, the 3 vaccines I'm going to be using in the UK, these are not licensed vaccine. They're vaccines licensed for emergency use.
Correct.
Now, hopefully, over the next few months, as we get more and more data, as we get more and more data, we're going to have better data about things like adverse events. And on that basis, we'll get the vaccines, hopefully, fully licensed. But this is where it's so important. If anyone, make sure if you're running your clinics or your mobile centers or whatever, you have good data that's returned to your coordinating center, so we can work out what side effects people get and what adverse events. And I'm not particularly worried about side effects, because I think we know what they are: local reactions and a bit of systemic features. I'm more concerned about adverse events that we haven't identified yet.
Yeah, actually, to be frank, David Baxter, when we sat through with the last webinar, I think it was in the month of August or early September, we never thought this disease would drag on this long, and it has. We never thought that vaccines would be ready this early, and it has been ready. I think it's actually kudos to the team of scientists who have toiled.
Yeah.
Ultimately, it is up to us to make it successful and get rid of the disease from the face of the earth to be more productive.
I completely agree with those sentiments. I don't think we're going to get rid of it off the face of the earth, because it's a zoonosis. And traditionally, the only diseases you can get rid of are human-only pathogens like polio and smallpox. But I completely share your sentiments. I do wonder, and it goes back to a question that was asked earlier about mutation, about whether it will become a sort of influenza-like illness that we'll have to vaccinate against it every year. You do wonder about it, because I'd wonder. I will have had. Sorry, if assuming I get vaccinated, now one of the questions will be, I wonder how long my immunity is going to last. And it may be that, for example, I know flu vaccine doesn't work very well in me. I have to have one every year. Am I going to have to do the same for SARS coronavirus too? And is that going to reflect both my declining immunity and the emergence of different strains each year, as you get with flu? Don't know.
True. That question cannot be answered right now. I think the future, we don't know what it holds for us. Let's wait and see. I think it has been overall an absolutely fruitful session we had, Dr. Baxter. Thank you so much. You have been excellent. I think you have covered everything, and you have answered a lot of questions. I think everyone is happy. There is no more question in the chat box, and even mine. Thank you so much. Thanks, Shashi, for arranging this, and Step One for the fabulous work.
Thank you so much, Professor Baxter, for giving an amazing presentation and for giving us the latest update on vaccine and the new strain on COVID-19. And thank you, Dr. Shashidhara and Professor Madhusudan Upadhyaya, for taking time from your busy schedule and doing this wonderful session for us.
Thank
Thank
you.
you. Thank
Thank you,
you.
Supriya. Thank you, Shruti. And thanks, David. I think you got a clinic and you